Okay, good afternoon, everyone. See you again for the second time in this week, huh? Okay, all right. Our last lesson, we started with this revisions on chapter 3. We go back to chapter 3, This chapter 3 are gravitational, okay? So we study about gravity, gravitational law. You studied about Kepler's law. Then you study this man-made satellite, all this kind of thing, right? Okay, I believe most of you you find it a bit difficult for your chapter 3, right? Because I believe most of you you did not follow the lesson properly lah. In school, I think you never follow this lesson in school. You only follow through online, right? Okay, so because of this, now I've almost want to finish chapter 4, right? So I come back to chapter 3. Okay, I don't want to go too far lah, huh? I come back to chapter 3 and then do some revision for you all. Hopefully, why now, Chao Yi? Hopefully, you will learn something you missed earlier. Okay, all right. Let's look at the paper now. Okay, I share the paper with you now. All right, the paper is not this one now. Yeah, this side of paper. Okay. In your hand, you have this paper with you or not? This side of paper. Okay. Last week we did a part of it already. Okay, we stopped submit. So you have this paper now. Okay. Before I go any further on this paper, right? Okay, now I want you to look at this set of paper. You also have this paper, right? Okay, class. You go slowly lah, huh? You see got someone coming. Okay, so when someone coming, so you pour out from the top, right? You block me one. So I have to let them come in first. Okay, this set of paper, oh, another one come in. Okay, I hope you all can take your time to read many times, to read through it again. Because I share with you the set of paper with the complete answer. I remember I shared with you in the group. Okay, this set of paper there are many pages. Very long one. Okay, but I take a little bit time to scroll up lah, huh? The whole chapter is here. With the notes and also the answer. This chapter, this set of paper, you all have or not? This set of paper now is I think it's 20 over pages. The whole set of paper, okay, including the notes plus the answer. I share with you in the group already. All the answers are here. I think I share with you in the group, right? Everything. Okay. For now, I want you to look at the last page of the paper. Last page. Let's go to the last page. You see, there's a lot on. You see, you look at the paper. I'm going through page by page. You see a lot of answer notes here. Okay. So you must read the paper. It's in your WhatsApp group. You can go and see. Actually, I shared with you already. The paper with a complete answer. Okay. And I still scroll down until the last page. Okay. And see, last part is man-made satellite. This one also we have discussed, right? Okay. And the last one is here. Okay. It's somewhere here, the last page. Okay. All right. Now you look at the last page. Okay. I will talk something about this on this page of paper with you, last page. Okay, basically, this topic, right? Gravitational. In this topic, right? So you learn. Hold on. Let me take out a pen first. Okay, I want to take out a pen. A moment. All right. The title is gravitational. You see here, gravitational. Okay. Actually, in this title, right, topic, you learn 3 subtopic only. First one is here, Newton's law of gravitational. Newton's law of universal gravitational. This is first subtopic. The second one is Kepler's law. This one involving a lot of calculation here lah. Kepler's law. Okay. And the last subtopic was man-made satellite, also involving calculation a lot. Another one coming in. Okay. Now let us go through slowly one by one now. Okay. In this Newton's law of gravitational, right? You see here now, the first thing you learn was this formula, right? This formula is gravitational force between two objects. Any object, two objects, when we focus on any two objects in the universe, between the two objects, even though two students standing, let's say 5 meters from each other, two students standing also, we can assume them these two students are object, So between the two students also, they have a force. So this is called gravitational force. So you look at this formula gravitational force between two objects, any object between two objects, okay, is G, big G is a constant, universal gravitational constant. Then product of the masses M1, M2, okay, the product of the two masses divided by the square of the distance between them, R squared. This formula is the first one you need to remember okay. This formula very common for you to use and to find gravitational force between two objects, okay. So this is the first one you learn. The second one is this formula. This is a gravitational acceleration. The gravity acceleration is a formula. Gm over r squared. The second formula This formula is used to find gravitational acceleration, means the acceleration of the gravity We are using this formula. Okay. This actually this formula come from here one, you cancel one of the m, so you get this Okay. The big G don't need to worry so much. Big G is only a constant. Universal gravitational constant is a constant only. Mass is a m and r, when you see the r referring to distance between two objects or the radius of the planet also can. Okay. Then here for this formula gravitational force, right? So you supposed to know how to solve the problem. Two bodies that rest, okay, two objects an object above surface of the earth, you also learn how to calculate the force, right? One object above the surface of the land, surface of the earth. Another one is the force between the earth and the satellite, right? Also two objects, right? Earth and satellite. And even between the earth and the sun, also two objects. Also, you can calculate the force between the earth and the sun, right? So these are the things you have learned, Okay, then for knowing this formula, gravitational acceleration formula, right? Okay, then you will come out with this another important formula, okay? This formula is for you to find the mass of any planet. Determine the mass of the Earth and the Sun using this formula. You want to find the mass, right? You take G(r) squared divided by big G. R is the radius, is the distance. Okay? And this formula, when you substitute something into it, you will get another formula, this one. Okay? So these two formulas are the formula you can use to find the mass of the Earth, the mass of the Sun, or mass of any planet. You want to find the mass, so you either this formula or this one, right? Okay, the next one you learned was centripetal force. Okay, centripetal force. Okay, centripetal force means when anything surrounding, for example, like The moon. The moon is surrounding the Earth, orbiting in the circular shape, isn't it? So what makes the moon circular, the Earth in a fixed position is because centripetal force. It's a force, This centripetal force is the force to hold the planets in a fixed position so that it can orbit. For example, Earth can orbit the sun, right? So why? Because Earth having this centripetal force. Okay, when you have this centripetal force, is something like a force holding the planet in a fixed position. Okay, so the formula is this formula. Remember when you want to, but this question seldom ask you to calculate one. Okay, in the SPM level, seldom we involve calculate of this centripetal force. If in case they ask you to calculate centripetal force, right, this is a formula. mv squared over r. You must know the mass, you must know the speed. Okay, orbiting speed, how fast the planet orbit, the speed, square of the speed divided by the distance r. Okay. Okay, this one is roughly in your lesson 1. Okay, lesson 2 will be Kepler's law. Actually, among these three, I will say Kepler's law is the most important, in your chapter 3. Okay, Kepler's law, I want you to focus to three laws only. First, second, third. Okay, the first law is the ellipse. The key word is ellipse. All the planets are actually they are orbiting, right? They are orbiting in the universe with the sun as a focus. Sun as a focus like Earth, Mars, Uranus, all these, right? They are orbiting the sun one, Okay, they are orbiting in the shape of ellipse shape So this is Kepler first law. Kepler first law, no calculation, only involving the word ellipse only, ellipse. So he was the first scientist who mentioned the shape of the orbit is ellipse shape, ellipse, not a perfect circle, it's ellipse shape. Okay, so this one is Kepler first law. Okay, now you look at the second law. Second law, what he said, he said this area same as this area, Okay, this is a sun. This is a sun. Okay, when a planet is orbiting the sun, okay, for example like this this is the sun, okay, is orbiting the sun. Okay, what happens is when you draw a line from the sun to the planet, right, you draw a line and then you let it move the same time here to here and move here to here. If the periods are same, they say here is 20 days, here also 20 days, and then it will cover the equal area. That's it. When the time taken to move from here to here and here to here, when the time are the same, it will cover the same area. This area S1, S2 also same one. This is Kepler's second law. Same area at same time interval. Understand? Remember this one is very important. Kepler's second law. He said provided time taken from here to here and here to here, same time. So it will cover the same area. When you use mathematical formula to calculate the area, you get the same area Area 1 equal to area 2. This is Kepler's second law. Okay, second law. Okay, the third Kepler's law, you see here. Third, okay, also this is the sun. So the planet is orbiting the sun, right? Okay, now Kepler say what, he say there's a relation between the periods and the radius, the orbital radius. The radius, he say what, square of the period to cube of the radius, right, is equal to a constant. Or maybe we say like this law, we say square of the periods of oscillation, right, is directly proportional to cube of the radius, the orbital radius. Radius referring to this distance okay. This is Kepler's third law. This is very, very important Okay, then out of this Kepler's third law, right, then you have this famous formula. T square 1 divided by R cube 1 equal T square 2 divided by R cube 2. You got 1 here, 2 here. This is T square. Here also T square. Here is R cube, radius cube. Here is also R cube, but you need to differentiate both here 1, 2 there 2. Okay? Different situation now, 1 and 2. So Kepler's 3 laws, first, second, third. Okay? Formulas. Okay, now man-made satellite. This is the last one you learn more. Okay, man-made satellite usually you focus into these two formula. You find the speed. Okay, so this is orbital velocity. Orbital velocity means the speed of the satellite to circulate the Earth. They must have a certain speed. They have the certain speed to the satellite orbiting the Earth, right? Then only the satellite will have enough of this centripetal force. Centripetal force, so that this satellite can stay constant in that particular position and orbit our Earth. Understand? That's why it's important. The scientists before the scientists send a satellite into the sky, right? They must know how fast the satellite must travel later on, because the satellite might move in a certain velocity, then only the satellite won't fall down. So it will stay there, stay in a certain fixed position, and then satellite is orbiting the Earth. So that formula is called orbital velocity. So use this formula, Gm divided by R. Okay. All the scientists must calculate the speed before they launch the satellite. Because after he launched the satellite into the sky, they have to push the satellite to move in a certain speed. This is a formula they calculate how fast the satellite must travel. Then only the satellite won't drop, won't come down. Okay. Another formula is escape velocity. This is another velocity, another formula. Okay. We just add 1, 2, a number 2 here only. This is escape velocity. Escape velocity means is a minimum velocity required for a planet to escape from the gravity. Okay. For example, here you want to launch a rocket, right? Rocket into the outer space. So this rocket must be able to overcome the gravity, right? So to overcome the gravity, so the rocket must have minimum speed. This minimum speed required to escape from gravity, right? We call it escape velocity. Also use this formula to calculate. So you see, there are many things the scientists need to calculate. This one to calculate escape velocity. This one to calculate the orbit velocity, orbital velocity. Okay, now, man-made satellite, we have two, right? Geostationary and non-geostationary satellite. Okay. Geostationary means is the satellite which orbit the Earth, right, with the same speed where our Earth rotates. One day make one round. Okay, you see I must tell you, our Earth actually in 24 hours our Earth make one turn 24 hours, 1 day Okay, so this geostationary satellite also with the same speed, also 24 hours. 24 hours it will make one round. So meaning that this geostationary satellite is a satellite orbit the Earth with the same speed with our Earth. Okay, that is called geostationary. Whereas other than geostationary is non-geostationary satellite. Okay. Okay. Last, when you know this formula, right? Solving problem involving the escape velocity of rocket. Okay, moon, okay, rocket from the Earth, one go to the moon, go to the Mars, or go to the sun, right? Okay, this is roughly what you have learned in chapter 3, Okay, so now we go back to the question. Okay, you guys got any question to ask or not? Anybody want to ask any question? Anyone want to ask any question here? Very quiet only. I don't know whether you all listen one. You got listen to me or not? Are you guys listening to me? Let me Chong, you listen or not?
Got, sir.
Got listen. Terenто, are you listening? Teren. Terento. See, this one no response one. No response means I disappeared already. I don't know what happened. You Tong? Oh yeah, Terento got a yes, sir. Okay, he replied. That means he was there lah. Okay lah, Teren. Okay, Long Jia Wei, are you there?
Yes, sir.
Yes, are you listening just now? You listen or not?
Yes.
Can one you? Are you there? Can one you? Can one you? Can one you say yes? Okay, she replied. Okay, thank you. Can one you? And you Tong, I think okay lah. All right. Let's go back to the question. We answer the question. Okay. Can you open up your question paper now? We have to finish discuss all the questions along. Okay. The question paper Okay, last week we stopped at summary. I don't know which question already. I think it's Kepler's law one, isn't it? Here. This summary here. Here, I think it's here lah. Is it correct? Here got mouse, got red, like the red sound. Someone should have got to switch off your microphone, Who is that? Okay. Off the microphone now. Okay. I think we stop here. Question number 14. Okay. I look at your paper now. So I think Kepler's law 1 we answer already. 2 also answer. 3 also answer. Now is P, prove the Kepler's law 3. They ask us to prove the formula T squared over R cubed 1. That formula. Okay. You have to be ready now in your exam. They will ask you to prove the question, Kepler's law formula. Okay. So to prove the formula, you have to start somewhere here, Okay, we start from here. This is first, this formula is mv squared over r. This is what actually? And this gm1, m2 over r squared. This is gravitational force between two objects, isn't it? Gravitational force between two objects, right? And this one is mv squared over r. This formula, okay, I don't want to tell you direct now. Okay, this one I told you already, gmm over r squared. Okay, this formula actually is from gravitational force, the Newton gravitational law. Correct not? What about this? This formula come from where? Chao Yi, can you tell me this formula come from where? This formula comes from gravitational force. What about this formula? Chong Chao Yi, Yong Jia Wei, this formula come from where? Come from?
Centripetal.
Yes, very good, very smart. Centripetal force. Also force, right? They say the two forces are the same. They put them equal. This is centripetal force, mv squared over r. This is gravitational force. Both are forces, so same lah. So they equal them. But now the v, because v is 2 pi r over period r. This is a speed for a satellite or to make one round. One round is a circle shape. We consider is 2 pi r, correct? Not 2 pi r, the circumference divided by the period. Then to find the speed, you take the circumference 2 pi r divided by the period, the time. Okay? So you take this v equal to 2 pi r over t, substitute here. V square, so you square the whole thing. You put it here. Then after you substitute the v with this one inside here, right? You simplify it, you will get this. Okay? The one I do want to show you how you do yourself. You put this one inside here, you square it, then you simplify here, you get this. 4 pi square r over t square. And now, one more step to go. Okay, so we want to find t square. Okay, this one cross over the gm bring here. R square multiply here, so become r cubed. Like this, this one crossover multiply the t square bring over, okay, and the gm bring down. Okay, so you get this famous formula. Then from here you see t square directly proportional to r cubed. Is proven the Kepler's law 3. T square directly proportional to r cubed. Okay, this is a constant now. 4 pi square over gm is a constant. This is how you prove the Kepler's law equation, T square equal r cubed. So remember this step, wait, you must learn one, Like AMX, you are supposed to learn to prove something in AMX from 5 chapter when you go to trigonometry. So now in physics also, what they will ask you to prove the Kepler's laws, third law formula one, So you think this one equal this to start, and this one substitute, and then you do a lot of things here, then finally you prove the formula. Okay, Understand? YPM, this YPM, who is YPM? May I know your name, YPM? Who is YPM? What's your name? YPM? No sound. I see the mic is open, the on, but no sound. YPM. Cannot hear what she say. Okay, question C. Now look at the third question, C. Satellite with this meter away from center of the Earth. Okay, this is a satellite this far from the center of the Earth. Orbital period, this is P. Okay, the moment you look at the question like this, you are given the distance, which is R, and then given the period T. Straight away, you know already it must be Kepler's third law formula, because T square R cube. This formula straight away you know already, T square R cube. Because given you the R, the distance, and given you the period, so you must use this formula. Calculate the orbital periods of satellite if the satellite is 2.5 10 power 7 away from the center of now different distance already. Just now this was the distance, then the period is this one. I think because if I forgot to switch off the mic, I off the mic now. YBM one. Okay. Calculate the orbital period. Okay. When distance change already, you find a new period. So use this formula lah. Okay. First period this one. Put it inside here. Square. T square, right? Period is here. First one you put here. R, the distance, first distance was 4.2 10 power 7. Substitute cube. Okay. Do it carefully. Then equal to T square number 2. This one you asked to find the new period, where the distance now R become 2.5 10 power 7. Then you put here power 3, right? Okay, now use your calculator, do it carefully. All the calculation here involving very big number one, so you have to do it carefully. Even though in the exam, you must do carefully, practice using your calculator, okay? So you press here, this one multiply here, divide by this, then you get T square equal this value, then square root it, finally you get this answer. Okay, copy the answer. Then can you understand the solution or not? Sima, do you understand? Sima?
Yeah.
Yeah, okay, thank you, Sima. Sima very attentive. So the moment I call you, you are there already. So very good, Sima. Okay, finish. Can Man Yu, are you there now? Huh? Can Man Yu? Can Man Yu? No sound one. No sound mean the fellow chabut already, I think. On the mic, see, she reply here. Yes, sir. She typed it, yes, sir. Another thing, everyone, I'm talking to you, listen here, please. When you type anything in the chat, like chat, can you put for everyone, can or not? So that everyone can see, at least sometime I click on it, to pop up, then people can see, everyone also can see, right? Don't put privately, when you chat, no secret talking here one, okay? No. Yeah, understand that? You want to ask any question, anything you don't understand, so you just type and then make it for everyone. Can or not? Follow the Form 5 student now. Form 5 student, they are very sporting one. They never put private one, they let everybody see one. Okay? Yeah. So remember, you want to ask anything, just type in the chat box here, but put everyone, please, okay, thank you. Okay, question 15. This question. Jupiter take 12 years. This is 12 years means this is period to orbit the sun. While Saturn take 30 years, another period for another planet side, 30 years to orbit the sun. So straight away you know already use this formula, Kepler's third law. Okay, T square over R cube, put 1, T square over R cube, put 2, 1 and 2, different planet mark. Now this one 12 years, put here. This radius are 778 kilometer. Okay, I can leave it kilometer lah. Because here kilometer, here also kilometer, so they can cancel off and only change to meter lah. Okay, so for this Jupiter is 778. Then another planets the period 30, so you put here 30 law. So you are asked to find the distance of this new planet Saturn from the sun. So find the R, R2, right? Quite simple. Okay. I think you know how to solve the equation to find the R cube, R2, right? Okay, use a calculator. Of course, you need to use a calculator. Okay. Then you get this answer, right? Some of you already did the answer. I know. Now you can check your answer. Okay. Understand? Then you can see from here, Kepler's third law, a lot of calculation, Most of the question they focus on Kepler's third law one. Okay. Next, 16. I'll read the question. The horizontal distance of Ceres and Haumea planet, there are two planets from the sun, 1.3 times and 2.3 times of distance of the Earth. Then that means now they give you the distance is how many times the distance of the Earth, This is 1.3 times, this is 2.3 times the distance of the Earth from the sun, right? Then Ceres planet take 1.55 years of orbit, the period. How much time does Haumea planet take to orbit the sun? To find another period for another planet, so same formula. Okay, now you see. This sun is for Ceres, this is for Haumea, so you just substitute lah. This period is 1.55 because it's given in the question, 1.55 years, right? And this distance was, the sum mentioned, right? 1.3 times the distance of the Earth. Distance of the Earth from the sun is this one, 1.511, not given here, So 1.3 times this distance of Earth from the sun, then keep the whole thing, Then for another planet, you're asked to find the period. So now the distance is 2.3 times the distance of the planet Earth from the sun. So use of calculator once again, you see all power 3, power 3, power 2, a lot big number, So press carefully, don't make mistake. Your fingers must do it carefully, okay? Then t square, you get 13.3, square root, you get 3.65 years, okay? So far, okay, can understand all this, you copy down, please. you must have the paper with you lah. I don't know how you have to find a way to print the paper. You really cannot print, right? Okay, you never mind. You copy down the answer on a piece of paper lah. At least you must do that lah. Please You don't have the paper to now. You maybe your house no printer yet, or the printer no ink already. You cannot print now. You can print later, but make sure you copy down the answer now. Okay? Can or not? Can one you understand lah? Can one you? Still no sound. Can Leon understand?
Understand?
Can Leon, you print out the paper or not? Can Leon?
Yes.
You can print at home now.
Yeah, but
Then
almost no ink already.
computer shop I think open already right now. Is it open now? I
Don't
think
know.
open maybe you can go and buy already. I think it's open already, the computer shop.
Oh, okay.
Most of the shop, the computer shop is also open now. Okay. Yong Jia Wei, what about you? You print out or not? Yong Jia Wei,
Yes.
you also got no problem to print out at home now.
No problem.
Then okay lah, good lah. What about you, Shima? Shima, you can print at home or not?
No, I haven't finished. I'm using in phone.
You're using handphone now.
Yeah.
You copy down the answer?
Yeah.
Yeah, okay, thank you. Some of you, I know you're very smart one. You don't copy, never mind. You screenshot. When you are looking at your handphone, you can screenshot the answer lah. Okay, up to you lah. Yeah, number 17. All right. The sun is here. Planet X, planet Y. Okay, the distance given, and also all the masses are given. The mass of the sun, the mass of the planet X, planet Y, right? Calculate the gravitational force between sun and X here, between these two, right? So the formula to find the gravitational force between this and this, between two objects is F equal G m1 m2 over r squared. Do you remember the formula? Okay, big G is this value, no? The constant G, this value, big G, mass 1, the mass of the sun, no copy. And mass 2, m2, mass of planet X, all put down, very simple, big G, m1, m2, this is r, the distance between them, given already 1.6, but it's in kilometer. Kilometer, you have to times 10 power 3 change to meter. Okay, this one change to meter lah. Square. Then that's it lah. So the rest, use of calculator. But of course, please do it carefully. Then you get this answer. This is a gravitational force between the sun and planet X. Okay, Yu Tong, where are you, Yu Tong? Ngu Yu Tong, where are you?
Yes, sir.
You get this answer or not? Do you get this answer?
Yes.
I know she very hardworking one. She most probably she already answered the question. She got the answer lah. Okay, thank you, Yu Tong. Some students are very hardworking one. Okay. Yeah. All right. Next question. Most probably, I think they ask you to find the gravitational force between another planet. See what is that? Okay. Go see next one. Between X and Y. Okay. You do the same formula. Between X and Y lah. Yes, same lah. G m1, m2, and then the distance, that's it. Okay, this is mass of the planet X again. This is Y. Between X and Y must take the mass of the X, mass of the Y, and then this is a distance between the X and Y. Okay, change to meter lah. Then you get this answer. Okay. Okay. Very fast, I can finish this one. This one I think very okay, simple one. Okay, now we move to question 18. Question 18 na. A satellite with a mass, this one is 4.210 power 7 meter away from the center. This is a distance. This is a mass. This is M. This is R. This satellite is geostationary satellite. Okay, now they ask you, what is meant by geostationary? Just like I told you, right? Okay, the answer what is, okay, just see the answer lah. A satellite that revolve, R-E-V-O-L-V-E, revolve means circulate lah, turn the Earth at the same speed as the Earth orbit. I told you, right? It surrounding the Earth with the same speed of the Earth turning itself, okay? A satellite that revolve, V-O-L-V-E, okay? The Earth at the same speed as the Earth orbit. Okay, the next one. What is the function of geostationary satellite? Okay, the function, you know, like common sense now. As a communication satellite for telecommunication, this is the most important now. Mainly now the satellite carry only two important functions, you know. The first one was this lah for telecommunication, right? The second function for satellite is weather forecast to check the weather, okay? Weather forecast, that also very important using satellite one, you know. You know this Google Earth, right? And even though these ways they want used to go direction, find direction, go to certain place one, they are taking the map of the Earth, right? Using the satellite now. This Google map, right? How the Google go and take the pictures of your house, even your house, you go inside Google map, I tell you, you type your house address, you don't believe me, later on you try. You type your house address inside the Google map, then you click search, and then you see, don't be surprised, your house picture will come up. Yeah, you believe me, there means no secret in the world, you know. Even your house also, he got the pictures. Okay, the only thing he did, what is on your house number, they put zigzag, your house number, mosaic, you cannot see. And your car parking in front one, the car number plate, they also cover it. Okay? But you can recognize it's your house. Later on, you want to try Google Map, you can try type your house address, and then you can search. Then your house number come out. Your house picture also come out. Then you got a shop, you know, no secret in the world now. Yong Jia Wei, understand that? Yong Jia Wei.
Yes.
Later on, Yong Jia Wei, you try. You don't be surprised your house picture come out.
Okay.
Yeah. Next, calculate the velocity of a satellite. Okay, velocity of satellite means use the orbital velocity formula. This one, square root gm over r. Okay, gravitational constant g. This value very often we use one. You better memorize it. Constant g, always use one. And this is a mass of Earth 6 times 10 power 24. Then the distance, the radius. Okay, the radius not given in the question mark. The radius here, 4.210 power 7, the distance. And then use a calculator, calculate, you get this answer. So this is the velocity of the satellite, so which is very, very slow. Okay. Yeah. Question 19. Read the question. To escape from the gravitational pull, a rocket must achieve escape velocity. You want to escape from it, right? Mass of the Earth it is, radius of the Earth, the distance. So what is meant by escape velocity? How to answer? What is meant by escape velocity? Hashini, are you there? Hashini?
Yes, sir.
Can you roughly answer what is escape velocity?
Minimum velocity needed to escape from the Earth's gravity.
Yes, correct lah. Okay, but to be a more appropriate answer should be like this lah. You see, This one more standard answer. Minimum velocity needed for an object to overcome gravitational force to escape to the outer space. Okay, copy down the answer. All this definition, you all must know, is a minimum velocity required for an object. This object is normally referring to rocket, satellite. Satellite, you want to carry the satellite, go out to the outer space, right? Or the rocket want to go to the moon, for example. You might escape, right? So you must have the minimum velocity to escape from the, overcome the gravitational force to escape to the outer space. Okay, next, I ask you to calculate. You know the formula, right? This one is orbit velocity. Then escape velocity, same like this. You add a number 2 here only, 2 gm over r, that's it, okay? Right? See the answer, 2 gm over r. 2 times the big G constant value. This is the mass of the Earth, and this is a distance. The distance change to meter. That's why I add 30 here. This is kilometer, so add 30 become meter. And then you get this answer. Remember this number, 11,200 meters per second. I see. If you want to escape the gravity, go to the outer space, right? You must fly with this speed, 11,200 meters per second. Can you do that? Sima, can you do that? Can you fly that fast to escape?
No.
You're not, isn't it, Sima?
Cannot.
Let's say you want to escape from the Earth, right? From the gravity. You have to invent something, a rocket, so that you fly with this speed. This is only the minimum speed, only minimum. You must be faster than this. 11,200 meters per second. Can you imagine? Just in 1 second, you can travel 11,200 meters very fast. Okay. Normal aeroplane cannot have this speed. Rocket can, rocket very fast. Okay. Right? Once a rocket launch exploded, it can go faster than this. That's why the rocket can escape from the gravity. Speed is very important. Okay? I talk a lot of nonsense. You all got listen to me or not? Yeah, we move on. Okay, C. If the velocity of rocket 8,000 only, this rocket around C1, 8,000 only, will it be able to escape? The answer no, cannot, because its velocity lower than 11,200. The escape velocity. So very straightforward answer. If your velocity only 8,000, no way you can escape, because you must have minimum 11,200. Okay? So that's the answer. Yeah? Can you understand?
Understand.
Okay, question 20. Also escape velocity, they ask you to calculate. So straight away take the formula, 2gm over r. Take all the value inside, gravity, this is not gravity, but constant g put inside. The mass, here mass, okay, mass of the mass. If you want to escape from the mass, right, the planet mass, right, you must take the mass of the mass here, okay, and then take the radius, the distance, 3390 kilometer. Remember, change to meter, at 30, and then the rest is up to you already. Use your finger, press your calculator carefully, so that you come up this answer, okay? Then, what's you made, okay?
Yes.
Okay or not? Can I understand?
Can follow.
Okay, good. Mandy, do you understand? Mandy Tay. Mandy Tay, understand or not? She only type only. Let me see what she type there. Privately again. And one you. Mandy say yes. Okay, good. Mandy. Mandy is good. No, Mandy type for everyone. This Kanban you still, this Kanban you was you type for private one, you know.
有完没完？是妈妈。
What happened there? Okay, question 21. This question, so you have to listen to me. I explain to you. Okay, the magnitude of gravitational potential energy, of a rocket with the mass of this on the surface of Cyrus is negative. Okay, the gravitational potential energy is negative one, you know, because it go against the gravitational pull. Because when the rocket fly away, go to the outer space, right? Okay, there's a gravitational force pull you down, go opposite direction, you know. Beside the potential energy, potential energy is going opposite direction with the kinetic energy. So that's why you put it negative. One negative, one positive lah. Okay. Calculate the escape velocity of the rocket. Okay. Now, the important concept we apply here is that, you know, we apply the principle of conservation of energy. Okay, the principle of conservation of energy say the total energy remains zero. When the planets are not moving at all, initially no moving, no traveling, no flying up. So initially the energy was 0, 1. That's why the total, you total up the potential energy and the kinetic energy is still equal to 0, you know. This concept is obeying the principle of conservation of energy. That's why we say potential energy plus kinetic energy becomes 0. When the rocket is flying up you have kinetic energy, but at the same time also you have potential energy because it goes higher, but in opposite direction. Okay. The potential, gravitational potential is because of the gravity, right? Gravitational potential, because of gravity. See now, when the rocket fly up, kinetic energy is going up. But the gravity is pulling it down. The gravity, that's why the gravitational potential energy is opposite direction. It's like negative. Understand? So potential energy no need calculate is given the value, but negative lah. Kinetic energy formula is half mv square. You remember that or not? Half mv square, half time mass times square of the speed. Half mv square, the formula for kinetic energy. This one negative, bring over here, become positive. Then this one divide and times 2, square root, finally, you get this answer. Okay? All right, copy the answer. All right, 22. 22 is a question want you to calculate the potential energy. I see potential energy formula is here. If you don't know, this is a potential energy formula. Negative GMM, the two masses divided by R of the distance. Calculate the magnitude of gravitational potential energy of a rocket. This is M1 on the surface of Jupiter. Then, based on your answer, calculate the escape velocity. Later on, find the escape velocity V. Okay, first, you calculate the gravitational potential energy. Okay, use this formula. Negative, take G constant value. Mass number 1. Mass number 1, this is mass of Jupiter. Okay, now Jupiter, mass of Jupiter given here. This one is mass of the rocket. Okay, both masses also have to put in now. Okay, divide by the distance between them, R. Distance between them given now radius, the radius of Jupiter. Okay, change to meter F30 use a calculator, then you get this value. This is the values of gravitational potential energy, right? After that, you do like the previous question. Potential energy plus half mv square kinetic energy equals 0. If people ask you why equals 0, then you say total energy initially should be 0. The principle of conservation of energy, right? Potential plus kinetic equals 0. You do like just now, let this one bring over, blah, 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 then finally you get this answer. Okay? Then can understand this, Someone WhatsApp me to ask question. Why don't WhatsApp me to ask question? You ask here. Ask straight away here. I don't know who lah. I don't know it's from 4 or from 5 students. They WhatsApp me, sir, how to answer this question. I will see WhatsApp later on. Okay, next. Question 23. Okay. A man has a mass 70. He is walking on a new planet that has a mass 4 times the mass of Earth. Very heavy. And the radius is same as the Earth. The radius also given. Calculate the gravitational force. This is a formula to calculate gravitational force. So constant G, mass 1 is the mass of the man, 70 kilo. Mass 2 is the Earth. Is it the Earth? Why I didn't times 4? No, let me see first. Calculate the gravity between the man and the Earth. Yes. So this one must be the man. And this one must be the Earth. That one 4 times the mass. That one is Tipu one, Trying to cheat you, Planet, he says walking on the surface of a new planet with a mass 4 times. 4 times, so some of you will think you need to times 4, mass of the Earth. But finally, you look at the question, it says, calculate the gravitational force between the man and the Earth. Man and the Earth means you only take the mass of the man and the mass of the Earth only. This one, the planet, this one, Tipu one. Only use, okay? Gm of the mass of the man, mass of the Earth, then the distance between them. Distance is given here, 6 times 10 to the power of 6, square, use of calculator, so you get this answer, okay? Yeah. Okay, question 24. Calculate the distance between two objects. The mass given m1, mass 1, this is mass 2. The magnitude of the gravitational force, the force given. So ask you to find the distance. You see the formula, same formula. Here is F equal constant G. This is m1, mass 1, mass 2. And you are asked to find the R, find the distance. Okay, find the R square, the formula. Then you find the value of R. So this one bring over, this one bring down. Okay, then you use a calculator, then you get this answer. Okay, check your answer now for those who already answer. For those who haven't do anything, so you better copy now. Yeah. All right, question 25. Read the question. Calculate the magnitude of gravitational force. Okay. Of attraction between two spheres. 10 and 6. Very simple. Use a formula. F equal to take G m1 m2 over R square. Okay. take G constant value, M1 10 kilo, M2 6 kilo. Then the distance is given 50 millimeter apart. Milliliter, milli means 10 power negative 3. This is milli, okay? 50 millimeter. Milli means you times 10 power negative 3. Then you square the whole thing. Okay? Use a calculator, then you get this answer. Okay? 10 power negative 3 is milli. Milli, you want to change to meter, so you times 10 power negative 3. Okay? All right. 26. Calculate the gravitational force. Same formula lah. Between the sun and the earth. Distance all got already. So you just use a formula. Constant G value. Mass 1. This one is mass of the sun, I think. M2, mass of the earth. And this one is the distance between the sun and the earth. Now you given 1.4 10 power 8 kilometer. Change to meter, so you times 10 power 3, 1000. Then use a calculator. So you get this answer. This answer is very, very big, 4.08 times 10 power 22 Newton. Very, very heavy. Meaning that the sun actually is holding the earth with this force, That means no chance for our earth to escape from the sun. Cannot, because you see the sun is holding us with this force, Power 22 Newton is very, very big. So the sun is holding the earth firmly with this force. So no way our earth can run away from the sun. The sun is a taiko there, All the planets are controlled by the sun. So no way this small planet cannot escape one. You see the force so big. Okay? But the force is invisible. You cannot see one, But scientists believe the force actually is there, If without the force, I tell you, can you imagine without this force, the earth, will the earth always stay here surrounding the sun? No, the earth will go and fly, go to other places, already never come back already. So one day you never see your sun already, because the earth go to some other places already, never come back. If no this force, the earth can disappear from the sun. Okay, but it never happened. 10 years, 100 years, 1,000 years, 2,000 years, every day when you wake up, you open up your eye, you still see the sun. So it's still there, I mean, the sun is holding us up firmly, okay, with this force. You understand. Okay, question 27. All right, here. Okay. Newton's universal law of gravitation. This is the first Newton law. We say what, The answer here is incomplete. So I will set it out. The formula is here. The force equal to G M1 times M2, mass 1 times mass 2 over square of the R. The R is the distance between the two objects. So now the answer is here. Force of the attraction between the object is proportional to the product of masses. Product of masses means M1 times M2, right? So we say force of attraction between the object is proportional to the product of the masses and inversely proportional to the square of R. But you don't say square of R, you say inversely proportional with the square of the distance between them. Okay, square of the distance between the two objects. Or just say inversely proportional with the square of the distance between them. Okay, got it? Got a complete answer or not? Ashini, do you get a complete answer?
Yes, sir.
Okay, very good. Chong Chao Yi, you get the answer or not? Chong Chao Yi, you get a complete answer. Chong Chao Yi, Wu Sao. Michelle Chua, are you there? Michelle Chua,
Yes, sir.
you get a complete answer, Michelle Chua.
Yes.
Okay, good. Okay, thank you, Michelle. Caleb, what about you, Caleb?
Yes, sir.
You get a complete answer or not, Caleb?
Yes.
Yeah, Miknish, what about you, Miknish?
Yeah, yes, sir.
Yeah, Dinesh? Dinesh still there or not? Dinesh,
Sir, got it, sir.
got the answer.
Got, sir.
Okay, good. Okay, next, Next one is they ask you to calculate the gravitational acceleration now. Determine the magnitude of acceleration due to gravity. Okay, I told you before, this formula. When you want to find the acceleration due to gravity, this is the formula. G equal big G m over square of R. Big G value very often you use, and you better memorize it. Or you see the big G constant value 6.67 10 power negative 11. Memorize here. Okay. And this is a mass of the moon not here, right? This value put in. Then a distance always referring to the radius lah. Radius will become the distance, right? Not square, okay? Then use a calculator to get this value. Very small gravitational acceleration, only 1.63. So this is a gravity on the Earth, not on the Earth, on the moon. Correct? Not on the moon. On Earth, the gravity is 9.81, or usually we round off to 10. Here is 9.81 or 10 meter per second squared. When you go up to the moon, the gravity is only 1.63. Okay, meaning that the gravity on the moon actually is only 1/6 of the gravity here. I think it's roughly 1/6 lah. 1/6 of gravity here. Okay. Okay, number 28. Straightforward. So I think you just see the answer, you understand now. By the force, right? The G, M1, M2 are square, the distance. But everything got like just substitute only. I think this one okay now. Copy the answer can already. Okay. Hong Chao Siang, okay or not? Hong Chao Siang
Okay, sir.
Okay, Terento, apa macam? Terento. Apa macam Terento? Terento no sao already. He typed in. Okay, let me see what he typed. Yes, sir, Terento say privately again. Type send to everybody lah, don't privately lah. Okay, Darren. Okay. Right, next. Question 29. Same formula. Another question, mass 1, mass 2, just put inside. Then over R squared, the distance. In the exam, I think most students can write this out. Then slowly, when the press the calculator, the answer will become wrong one. I don't know why. This one, my personal experience with the student now. When big number, they use calculator. Given them a calculator to calculate, also they will give you the wrong answer one. Yeah. Press too fast, and the fingernail too long. Sometimes they press the button sangkut. Yeah. All right. So you get this answer. Question 30. Two spherical object masses, mass 1, mass 2 given, Gravitational force also given 65. They want you to find how far apart, find the R. Nah. Okay, the force is here already, 65. Constant G value, mass 1, mass 2. Then you're asked to find the R. Don't make mistake. So the R bring up here, 65 bring down. Okay, press your calculator carefully. R square, you get this value. And finally, you square root, you get this. Very small answer. Okay. Yeah, I think okay lah. This one not difficult lah. All right, let's move on. Next question. 31. Same lah. I think you just copy the answer can already lah. The force given, constant G. Now they say the both of them having the same mass, you know. You say two spherical have equal mass. Equal mass, so you put M1, M2. Put both also put M now, because they are same mass, so put same no. The rest of the value given. So now M and M square become get this value. Then you square root, finally you get this. This is only simple mathematics lah. Yeah. Next question, you can see the answer lah. These few questions are quite simple, very straightforward. Okay, you can just apply the formula, put the number in, calculate, get the answer. Some are very hardworking students, I believe, already got the answer, and now just goyang kaki there, just check the answer only. That's all. Yeah. All right, question 33. Okay, we go to 33. Same. You just copy the answer. Two spherical object masses, center are separated. The center are separated of distance, mean the distance R. Okay. So put capital G, M1, M2, this is the square of the distance, so you get this answer. Okay, just check on it, okay? Copy the answer. Yeah, 33, now 34. 34 is a little bit different, but I think same lah. They ask you to find the distance. Okay. The force given, they ask you to find the distance. They say how far apart. Okay, how far apart means they ask you to find the distance R. So find this. Okay. So the R bring up here, this number bring down. So calculate here, divide. Okay, so you get this answer. Yeah, okay, very straightforward now. Hui. Okay, Hui. So far can follow, Hui. I also don't want to talk one, just type only. Hui say, yes, sir. Okay, thank you, Hui. Terry, go. What about you? So far, okay or not? Terry.
Yes, sir.
Okay, Chichen, okay? Chichen, Chichen, okay or not? Maybe I didn't pronounce the name correctly. Lim Yu Xuan, okay, Lim Yu Xuan. Chichen say, yes, sir. Okay, thank you. Kevin Lim, Kevin, okay.
Yes, sir.
Kevin, okay, huh?
Okay, sir.
Okay. Tan Cho Ming, what about you? Tan Cho Ming. Tan Cho Ming, okay or not? Tan Cho Ming also she type and I see what he say. Tan Cho Ming, yes, sir. Okay, thank you, Tan Cho Ming. Chai Pei Xin, Chaya, how about you? Okay or not? Chai. Chai. Chai also type. Yes, sir. Okay, thank you, Chai. Juling, okay or not? Juling, I think she had done all the questions already. Juling, get the
Yes,
answer
sir.
correct?
Yes,
Juling,
sir.
okay, Juling, okay. Kong Fan Xin, what about you?
Yes, sir.
Can follow.
Can.
And Ivan Razaru, this one, Razaru, the father's name. Are you there now? Ivan Slim Razaru. Not there, no sound already. Okay, we move on now. Now, 35, question 35. Okay, same lah. Question 35, same like just now. Question now, find the mass. Equal masses. So you put m here, the square. So find the m lah. But don't forget put kilogram here now. It's supposed to be your answer must have kilogram, because it's mass must have kilogram. Force given. Distance given 36 millimeter, like is it like that? Yes. 36 millimeter apart. So milli is 10 power negative 3. Okay. Your chapter 3, I tell you in your exam, you must have very good using calculator skill, you know. You seldom use a calculator one, especially involving the big number, like you find it very difficult, take time for you, you know. So remember, now must practice your calculator skill also, press. So make sure no mistake one when you use a calculator for big number. Even your mathematics sometimes also you don't involve the number like this, you know. This chapter 3, the number all very big one, you know. Because involving the universal object, all big number one. Okay. Okay, 36. Masses 8,000, 5 kilo. Center are separated with this distance. Find gravitational force direct. Substitute all the value. So finally you get this answer. Very simple. Okay, 36. Now look at 37. 37 same lah. Same formula. Just put all the value inside, calculate. Yeah, 37 same lah. Find the gravitational force. This formula used many times, you know, the gravitational force formula, big G m1 m2 over r squared, okay? Then the answer is 2.5, 10 power negative 18 Newton. Yeah. Sima can follow, Sima. Sima.
Yes, sir.
Yes, you didn't follow this chapter when when I'm teaching this chapter, you didn't follow, correct not?
Correct, sir.
Now you can follow lah, slowly lah, okay?
Mm.
All right, 38. Something like repeat the question. Mass 1, mass 2, the gravitational force given. So you ask to find the distance now. How far apart mean find the distance r. So use of calculator skill, you get this answer 1.5 meter. Okay, copy the answer. Okay, 39. 39 a little bit different. Yeah, ask to find gravitational acceleration. Calculate the G, okay? G means the gravitational acceleration now. Distance from the center of spherical, okay? All the value given now. This big G value, the mass, this value, and then the distance given. So you calculate carefully, you get this answer, okay? So this one is finding the gravitational acceleration now. The G means gravitational acceleration now. Okay, 40. Same. Calculate the G, calculate the gravitational acceleration now. So use this formula now, same formula. Take G m over square of r. Okay. So you get this answer 1.7 meter per second square. Yeah. Question 41, also same. Find the G. Find the gravitational acceleration of surface on the sun. This one on the sun, you know, it's crazy. What for when you find the gravity on the sun? You never go there. Radius of the sun given, mass of the sun given. Okay, you see, can you imagine the gravity on surface of the sun is this big, you know, 272 meter per second square. I mean, when you are already in the sun and you cannot escape one, you know, because you see the gravity of the sun pulling you down with this kind of acceleration. 272. Over here it's only 9.81 meter per second square, but in the sun, 272 meter per second square. Okay, you see how fast? Okay, 42. Same. Same thing, Calculate the gravitational acceleration of surface of the Mars. And 43, also same. All same. Same means they want you to practice using the formula to calculate. Practice make perfect, okay? Practice more make perfect. You don't correct not? Practice make perfect, isn't it? You don't correct. You don't. Sima, the
Yes,
face
sir.
Yes, you don't correct. Sima, show your face lah. Let me see you. See your hair how long already. Sima, you got cut your hair or not? Or you cut your hair? Sima. I can't hear what you say lah. Your mic, you off your mic already.
My mother cut my hair.
Or your mother knows how to cut hair.
And she see from YouTube.
Learn from YouTube, then your mother cut your hair. Then okay lah, good lah, huh? I'm still searching who can cut hair now, you know. Nobody want to cut. Never mind lah, huh? Okay. Okay, question 44. Same, calculate gravitational acceleration. Okay, so use the same formula. Just check your answer lah. Okay, all this show you answer, you check your answer lah. 44, 45, same formula. All are the same, asking you to find the same thing, calculate the gravitational acceleration. Check your answer. Your copy like this. That means you must practice the use of calculator and all. Later on, you don't just certify with the answer you copy. You have to practice. Take a calculator, you go and practice so that you also get this answer. Use your calculator, you practice. Use your calculator to calculate. Make sure you get the same answer. Yeah. All right. Question 46. Okay, 46 still the same. Calculate the gravitational acceleration. Same lah. No, just put all this value inside, calculate. Okay, all the same. Now you can copy first. Later on, you take out your calculator, go and practice. You tong your answer correct not? No, you tong. All your answer correct?
Correct.
All correct lah. You did all
Some
question.
wrong.
Some wrong. You did all the question already. You tong.
Haven't.
Haven't. So your school homework a lot lah. Correct not? Juling? Okay lah. What about you, Juling? Juling, have you answered all the questions?
No.
No. Not finished yet lah. You did half already, right? Correct not, Juling?
Yeah.
Okay. I know your school teacher also give you a lot of homework lah. Okay, 48. 48 a bit difficult already. Count you all listen. 47 all done. Okay, now 48. Okay, 48 is a Kepler's third law formula. Why choose this? Because you see, Titan, the largest moon of Saturn, is a planet lah. Has a mean orbital radius, mean the R radius of this value. So the orbital period, now you see the question given you, the orbital radius R. Another one is orbital period T. You see got R got T already. The moment you see got R got T, straight away use this formula. Kepler's law formula. Got R got T, got R got T, right? Okay. Hyperion, another moon of Saturn, orbit with the mean radius. This one another R. Use Kepler, like even stupid question that give you, they ask you to use Kepler third law to do. Okay, first one is period, put it here. The radius, put it here, cube. Then another planet's radius is 1.78, no here, 1.48. Then you ask to find the periods here. Also like that. But this one be careful lah, because involving cube here and also square, the calculation had to be a little bit more careful lah. Use of calculator, Cube, especially here, power of 9 already, then later on got power 3 some more. You must know how to press your calculator lah. And finally, square root of this, you get 21.3 days. Okay. 49, come back to this again, the gravitational force. Yeah, you Tong, you want to ask anything? Tong?
Huh?
You want to ask question? Accidentally you on your mic, right? Correct. Okay, 49. You just formula find the force lah, huh? Mass of moon is this. The mean distance of moon from the center of Earth is this. Use this data to calculate the magnitude of gravitational. When you see the moment you see gravitational force, straight away use this formula. Okay? Yeah. So the rest all blah blah blah. You put it, do it carefully. Here, especially the one given in kilometer, you must add 1,000. Change to meter. Understand? Then finally you get this answer. Okay, one more question on number 15. Okay, 50. If you need this one, then we stop. 10 o'clock already. Okay. Okay, the question 50, later on your copy first. I got something I want to tell you all because these questions are your copy first, copy the answer first. Okay, come. Now focus on the last question here. The planet Mercury revolves around the Sun with a mean orbital radius, the R. Mass of the Sun 1.99 times the Sun. Use Newton's version of Kepler's third law to determine how long it takes Mercury to orbit the Sun. Okay, now these questions are because you are given the mass, mass, so you cannot use the original Kepler's law formula. This one cannot, because this one only involve period and radius, period and distance, period and distance. Doesn't involve the mass, But this question they are giving you the mass, the mass of the Sun. So you must make use of the mass of the Sun. Okay, and then you are given only one period, one radius only. The other radius don't have, so no R1, R2. So cannot use the original Kepler's law formula. So use this formula. This formula I showed you just now, right? T square. This formula actually is used to prove the Kepler's law formula, right? T square equal 4 pi square over gm times r cube. It's still the same, It shows the square of period proportional to cube of the radius, right? But you only add this one here, 4 pi square over gm. Why use this formula? Because this question given you the mass of the Sun. So you have to use the mass, the formula with the mass is this one, because the m is here, right? So to find the question asks you to calculate how long it takes Mercury to orbit the Sun. 4 pi square, big G, mass of the Sun. This one is cube of the radius. The radius is 5 times 10 power 10 cube. Okay. I'm sure when you press here, you don't get this answer, correct? No? You don't believe you use a calculator and press? Then later on I tell you why. Use of calculator to press 4 pi square times this cube, divide by this again. Then finally you square root also, you don't get this one. Okay. Now I tell you what. To get this answer, right? This answer is in the units of day, Your answer from here, when you use a calculator to press here, right? The answer is in second. Okay, please jot down. When you use a calculator, you press here, right? You will get the answer in a unit of second. Not day one, That's why you need to change the second, change to day. Only you get this answer. From second change to day, how to change? Anyone can tell me or not? How to change second to day? How to change second to day? Well, I put here already, change second to day. How to change it? Tell Kevin Lim, any idea how to change second to day or not? Kevin Lim. Quiet already. You Tong, how to change second to day? You Tong? Okay, never mind, it's time's out. I just tell you lah. Change second to day, right? You divide by 3,600. You know that 1 hour, 3,600 seconds, correct not? And then divide again by 24. 1 day got 24 hours, isn't it? So meaning that you divide 3,006, then divide again 24. Okay? 2 times, Who is this, Zhong Zhao Yi said correct. Divide 86400. 86400 is 3,006 times 24. Okay, let me see, Yes, correct. 3,600 times 24, so you get. But Zhong Zhao Yi, you don't put private lah. You type, let everybody see, okay? So it's divide 86400. Okay. So okay, So remember, this answer after you square root is in second. So you want to change to day, divide 3,600, then some more divide 24. Okay. All right. So I stop here for tonight, Okay. Any more question to ask among you all? Any question to ask? No, Okay. Listen, next week we only have. Next week is Hari Raya week, right? So Monday no tuition, Monday no. So only Wednesday only. So next week only one time only Wednesday we have online class lah. Monday no lah. Monday you can rest lah, Okay. So remember, take good care of yourself. Continue to struggle. Continue to study. Whatever homework your school teacher asks you to do, remember to do. Don't be lazy lah. Okay. Enjoy your Hari Raya holiday. Okay, take good care of yourself. Okay, bye-bye.
Thank you, sir.
Yeah, okay,
Thank
bye-bye.
you, sir.
Thank you, sir.
Thank you, sir.
Bye-bye.
Thank you, sir.
Thank you, sir.
Okay, bye-bye.
Thank you, sir.
Okay, bye-bye.
Bye-bye.
Okay, bye-bye. Yeah, bye-bye now.